Hello learners, I am Dr. R.B. Malati, Assistant Professor at Chhattisgarh Swami Vivekanand Technical University, Bhilai. I welcome you all again to the course Fundamentals of Building Construction. In this lecture on painting, distempering and whitewashing, we are first going to talk about paints. Paints aren't just about adding a pop of color to your walls. They are like liquid compositions of pigments and binders when applied in thin coats dries to form a solid film. This not only gives your surface a beautiful decorative finish but also provides protection. With this background, let us see the characteristics of good paints. Your paint needs to form a hard, durable surface. You don't want it chipping or peeling off after a few months, right? So the first characteristic that we see here is tough and durable. Next, it should give your wall a good look. So the second characteristic is attractive looks. Third, it should be cheap and readily available so that you can easily get your hands on it. Hence, the third characteristic is affordable and available. Yes, then a hassle-free application with great coverage will be your fourth and fifth necessity. Next, it should also dry in a reasonable amount of time, importantly with no cracks, so you can move on the next step without delay. With all these good characteristics, this paint when applied on timber structure helps to prevent the timber structure from warping and decay. And the same while applied on metals, they protect them from corrosion. But when it comes to calcareous surfaces like lime and cement plaster, things are quite different because these surfaces are highly alkaline in the beginning stages and retain a lot of water during construction. So, when applying paint to these surfaces, it is important to consider the stored up moisture and the alkalinity. So, selecting a paint with specific characteristics becomes very essential. Therefore, an ideal paint that you choose for this purpose should be durable and form a hard surface to overcome issues like variable suction and surface imperfections. And also, it should effectively address mold and algae growth. With this background, let us learn the main ingredients that make up your paint. A paint generally is made up of the following constituents: a base, a dryer, a solvent or thinner, a vehicle or carrier, and a coloring pigment. Let us see one by one. First, the base. The base is a solid substance in the form of fine powder making up most of the paint. It is usually a metallic oxide and plays a big role in determining the paint's characteristics and durability. The common bases include white lead, red lead, zinc oxide, oxide of iron, titanium white, antimony white, aluminium powder and lithofoam. You can think of it as a base of foundation of your paint. It provides an opaque coating that hides the surface you are painting. So, next key ingredient in your paint is the vehicle, which is also known as carrier or binder. These are the liquid substances that hold all the different ingredients of your paint in suspension and makes it possible to spread the paint evenly onto your surface. So, the role of the vehicles in paint is to give paint its spreadable consistency and also ensure that your paint goes on smoothly and evenly. Here are some common vehicles you will find in paints. First is linseed oil. This comes in 5 types: raw linseed oil, boiled linseed oil, pale boiled linseed oil, double boiled linseed oil and stand oil. Raw linseed oil. This is thin but takes a long time to dry. It is often used for delicate work along with dryers. Boiled linseed oil, thicker and dries faster than raw linseed oil. It is great for general use. Pale boiled linseed oil, a light version of boiled linseed oil, often used for specific finishes. Then double boiled linseed oil. It dries very quickly, making it suitable for exterior wall. It is often requires a thinning agent like turpentine. Stand oil, a thicker form of linseed oil that provides a smooth finish. So, after linseed oil, we have the tug oil. Tug oil is used for preparing high quality of paints. It provides a tough, durable finish and is great for surfaces that need extra protection. Third, we have poppy oil. Poppy oil is ideal for interior work. It helps colors last longer, making your paint job look fresh and vibrant for a long time. And lastly, we have nut oil. Used less frequently, nut oil can also serve as vehicles in paint. Okay, by now I believe that you have a clear understanding of the two main ingredients of the paint, the base and the vehicle. Yes, the base gives the paint its opacity and durability, while the vehicle ensures that it spends smoothly and evenly across the surfaces. Now moving to the next step, we have dryers. And dryers are added for speeding up the drying process. These handy additives help speed up the drying and hardening process of paint by pulling oxygen from the air and transferring it to the paint vehicle. However, there are some important things to know about using these dryers. Dryers come in two main forms, soluble dryers and paste dryers. Here is what they do and how they work. First, soluble dryers. They are finely ground compounds of metals like cobalt, lead and manganese dissolved in a volatile liquid. They are great for accelerating drying times but can reduce the elasticity of the paint. That is why it is best not to use them in the final coat of paint. Next comes the paste dryers. These consist of metal compounds mixed with inert fillers like barytes and whiting, all ground up in linseed oil. The inert fillers serve several purposes. First, they reduce the overall cost of the paint, improve durability, modify the weight of the paint and prevent shrinkage and cracking. However, it is important to note that these fillers are sometimes seen as additives and their weight shouldn't exceed 1/4 of the weight of the paint base. I repeat, their weight shouldn't exceed 1/4 of the weight of the paint base. Common compounds used as dryers include litharge, red lead and zinc and manganese sulfates. A small recap here between. After clear understanding of the two main ingredients of the paint, the base and the vehicle, we learned that dryers in paint should soluble and paste forms. That helps in accelerating the drying time. Soluble dryers are good for quick drying but can reduce paint elasticity, while paste dryers improve durability and reduce cost but should be used within limits to avoid issues. Now, let us look into the next part of the painting, the coloring pigments. These are what that give your paint its vibrant hues and shades, turning a plain surface into a work of art. Looking into the different types and how they work, first we have natural colors, thick earthy tones like ochres, umbers and iron oxides. These pigments come straight from nature and add warm, natural hues to your paint. Take the Colosseum in Rome with its rich umber giving it the classic historic vibe. It looks as if those natural colors have come straight from the nature, isn't it? Then calcite colors. These are pigments that have been heated to high temperature to change their properties. Examples include lamp black, Indian red, carbon black and red lead, which offer deep rich colors. This can be seen at Gothic cathedrals. There you will spot deep lamp black in their stained glass that adds a touch of mystery and elegance. Next we have precipitates. These pigments are created through chemical reaction. Prussian blue, chrome green and chrome yellow fall in this category, offering vibrant and stable colors. Those stunning tiles of Sultan Ahmed Mosque in Istanbul are the good examples for this. Next we have lakes. Lakes are pigments made by dyeing inert materials like barytes or china clay. They provide a wide range of colors and are often used for specific effects. They are seen in the interiors of Victoria and Albert Museum in London. Lastly, we have metal powders. The powders of metal like aluminium, bronze, copper and zinc add metallic sheens and effects to paint, perfect for creating a unique look in the arts like the Gates of Paradise in Florence. Now you are curious to give the perfect shade for your project, and you can use a single pigment or mix different ones together. Here are some common pigments and the colors they produce. Black, it produces lamp black, carbon black, bone black, graphite, vegetable black and ivory black. And the blue, it produces indigo, Prussian blue, cobalt blue and ultramarine. Brown, it produces burnt umber, raw umber, burnt sienna, Van Dyke brown. Green, it produces Paris green, chrome green, green earth, verdigris copper sulfate. Red, it produces Indian red, Veneton red, vermilion red, carmine, red lead. Yellow, it produces chrome yellow, raw sienna, yellow chrome, zen chrome. So, to implement this, we should have an understanding on PVCN. So, what is PVCN? It is nothing but pigment volume concentration number. And what does it measure? It measures the concentration of pigment in a paint. This number simply tells us how much pigment is in relation to the non-volatile vehicle or carrier in the paint. For example, if painting is for prime coat on metals, the PVC ranges from 25 to 40, and if it is on timber, PVCN range 35 to 40. Then if it is for exterior surface of the buildings, PVCN ranges from 28 to 40. Then for semi-gloss paint, this PVCN ranges from 35 to 45, and for flat paint, PVCN ranges from 50 to 75. This helps us to choose the right paint for different surfaces and achieve the finish you desire. A recap again. We explored the vibrant colors of pigments from natural earthy tones to metallic sheens. The pigment volume concentration number is important in determining the right paint for different applications. A lower PVCN indicates higher durability and gloss, while a higher PVCN is suitable for flatter finishes. Okay. Now, lastly, we have solvents and the secret ingredient that make your paint easier to apply and help it penetrate surfaces. So, what solvents do? Solvents are added to paint to thin it out, make it easier to spread evenly. They also help the paint penetrate porous surfaces, ensuring better adhesion and coverage. One of the most common thinning agents used in spirit of turpentine, known for its effective thinning properties. Looking into the types of the solvent and the thinners. Oil paints. For oil paints, you will typically use spirit of turpentine, naphtha and benzene. These solvents help thin the paint and adjust its viscosity for smooth application. Next, we have spirit liqueurs. For spirit based paints, alcohol is commonly used as thinner. Next, for cellulose paint, methyl amyl acetate is a preferred thinner for cellulose based paint, helping them achieve the right consistency for application. Fourth, we have distempers. Water is a go-to solvent for distemper paints, making them easier to apply and clean up. One more point that you have to notice is when painting external surfaces, it is important to use solvents wisely. Turpentine oil, while effective, can be affected by weather conditions. Using minimal quantities of thinner helps maintain the durability and finish of your paint. Now, let us see how the paints are classified. First up, we have classification based on binders. Think of binders as the glue that holds the paint together. Here are the main types. Oil paints. These are your classic paints known for the durability and glossy finish. Next, we have paints based on non-oil resins. These include various synthetic resins that offer different finishes and properties. Then we have cellulose paints, quick drying and used for high gloss finishes often seen on cars. Water-based paint, easy to clean up and environmentally friendly, perfect for indoor use. Then some miscellaneous paints, a catch of all category for other types that don't fit neatly into the above groups. Next, let us look at how paints are classified based on the ultimate use. This is all about the paint is meant to do once it is applied. So, first the general purpose paints. These include primers, undercoats and finishing coats that are used for everyday painting purpose. Next, we have acid and alkali resistant paints. They are used in environments where the paints needs to withstand harsh chemicals. Next, we have fire resistant paint designed to resist flames. These are important for safety purpose. Next, we have fungicidal paints. These help prevent mold and mildew, perfect for damp areas. Next, we have miscellaneous paints. This includes specialized paints like anti-condensation and additional fire resistant paints. And lastly, we have mixed classification that covers a variety of specific types of paints. Here is a rundown. First, we have aluminum paints, reflecting and often used for radiators and metal surfaces. Next, we have anti-corrosive paints, protect metals from rust and corrosion. Third, we have asbestos paints, once popular but now mostly phased out due to the health concerns. Next, we have bituminous paints, waterproof and commonly used on roofs and underwater structures. Then we have bronze paint, which gives a metallic bronze finish. Then casein paints made from milk protein used for finishes, and the cellulose paint, again quick drying and glossy, often used for cars. Cement based paint, ideal for masonry and concrete surfaces. Celluloid paints contains tiny particles suspended in the medium, and emulsion paints, water based and easy to apply. Enamel paints, hard, glossy and durable. Graphite paints used for lubrication and electrical conductivity. Indoorless paints, low order, great for indoor use. And oil paint, classic and versatile. 15, we have plastic paint, flexible and resistant to cracking, and silicate paints, long lasting and often used on historic buildings. Then finally we have synthetic rubber paints, which is flexible and waterproof. Let us understand each of this in detail. First, we have aluminum paints. They are super cool. They consist of finely ground aluminum suspended in either quick drying spirit varnish or slow drying oil varnish, depending on what you need. When the spirit or oil evaporates, it leaves a thin metallic film of aluminum. These paints are fantastic for woodwork or metal surfaces and come with a bunch of perks like this: weather resistant, waterproof, highly heat reflective, corrosion resistant, high electrical resistant, excellent covering capacity and visible in darkness. Next, if you want metal surfaces to protect, anti-corrosive paints are your best friend. They safeguard metal from moisture, fumes, acids and rough weather, and it is made of oil, a strong dryer and coloring mixed with fine sand. These paints are cheaper and long lasting than the white or the lead paints. They do have a black appearance though. Typically, linseed oil is used in the mix. Next is asbestos paint. This special purpose paint is perfect for surface exposed to acid gases and steam, and for patchwork or stopping leaks in metal roofs. It is also great for painting gutters and other metal surfaces to prevent rust. What may be the main ingredient? Yes, of course, it is fibrous asbestos in it. Now, the next one is bituminous paint. Bituminous paints are made by dissolving asphalt, tar or mineral pictures in naphtha, petroleum or white spirit. These paints resist alkalis and are mainly used for painting structural steel underwater and iron water mains. They appear black and deteriorate when exposed to direct sunlight. Good example for this, the London Underground. Here the iron and steel components, especially those are submerged or exposed to moisture, are coated with bituminous paints. Next we have bronze paint. Now if you need to paint interior and exterior metal surfaces, bronze paints are your go-to. They consist of nitrocellulose lacquer and aluminum or copper bronze pigments. Thanks to their highly reflective property, they are often used on radiators. Think about the radiators in old buildings. Many of them are painted with bronze paints to give them that shiny metallic look. Next, we have casein paints. Casein paints are made from casein, a protein from milk curd mixed with white pigments. Available in powder or paste form, they are great for walls, ceilings and wall boards. You can tint them any color you want. For exterior use, a bit of drying oil or varnish is added to make them weather resistant. Take a look at the historic buildings and schools that often use casein paints. These paints were popular in the early 20th century schools and public buildings for the durability and easy application. Okay. Next, we have cellulose paint. Different from the ordinary oil paint, cellulose paints are made from nitrogen cotton, celluloid sheets, photographic films and amyl acetate substitutes. They harden through solvent evaporation rather than oxidization, offering a smooth finish that resists hot water and smoky or acidic environments. They are pricey, so they are often used for motor cars and airplanes. Next, we have cement-based paints. Cement-based paints are water paints which use white or colored cement as the base. No oil is used here. Available in powdered form, these paints are perfect for external surfaces because they are waterproof. Just mix with water to the desired consistency, you will get it. New surfaces need 3 coats while old surfaces need only the 2. For instance, many school buildings or community centers use this cement-based paints on their exterior walls. Next, we have colloidal paints. Colloidal paints are unique because they don't contain any inert materials. Their colloidal properties mean they take longer to settle, penetrating the surface deeply as they do. Look at the high-end art galleries and museums. They often use colloidal paints on their walls to ensure a deep, even application that enhances the overall appearance of the artwork. Then comes the emulsion paints. Emulsion paints contain binding materials like polyvinyl acetate, styrene, resin and other synthetic resins which makes them alkali resistant. They dry quickly, have great workability and are highly durable. The main film forming constituent is emulsified in water, so you can thin them with water instead of solvent. Plus, you can wash the painted surface with water. They are ideal for stucco, plaster, bricks and masonry surfaces containing free alkali. Next, we have enamel paints. Enamel paints are like the superheroes of the paint world. They contain metallic oxides like white lead or zinc white. And these paints dry slowly but form a hard, glossy, elastic and durable film. Available in many colors, they resist acid, alkalis, gas fumes and both hot and cold water. They are perfect for doors, windows, metallic grills and concrete stairs. Next, we have graphite paints. Graphite paints are black and are ideal for iron surfaces exposed to ammonia, chlorine or sulfur gases. They are also great for mines and underground surfaces. Next, we have interiors paint. These paints are made with white lead or zinc white mixed with methylated spirit. They also contain shellac, linseed oil, castor oil dissolved in methylated spirit, drying quickly without the use of turpentine. They leave a thin film of shellac and are perfect if you need a quick drying option without the strong paint smell. Furniture restoration often uses these paints. Next, we have oil paints. Oil paints are your standard paints with a base and a vehicle plus added dryers and pigments. Common vehicles include various forms of linseed oil, while bases can be white lead, red lead, zinc white, lithophone and titanium oxide. Applied in 3 coats, oil paints are cheaper, easy to apply and versatile, suitable for walls, ceilings, woodwork and metalwork. Just avoid using them in humid or damp weather, that is it. Plastic paints. Plastic paints use plastic as a base, offering quick drying, high coverage and a decorative finish. Plastic emulsion paint is particularly popular, containing compounds like vinyl acetate and acrylate suspended in water. A liter of plastic emulsion paint covers about 15 square meters of wall surface per coat and can be applied with a brush or spray gun. It is great for a quick and stylish update. Next, we have silicate paints. Silicate paints mix calcinite and finely ground silica with resinous substance. Silica gives the paint excellent adhesion, resulting in a hard, durable surface that can withstand extreme heat and is unaffected by alkalis. Plus, it doesn't react chemically with metals, making it a reliable choice for various surfaces. And if you notice in historic building facades, often use silicate paints because of their durability and resistance to weathering. Next, we have synthetic rubber paints. These paints consist of synthetic resins dissolved in solvent and mixed with suitable pigments. They are resistant to acids, alkalis and moistures and can handle rain, sunlight and weather changes without losing their colors. Synthetic rubber paints dry quickly and are moderately priced, making them ideal for cement concrete and both interior and exterior masonry surfaces. For instance, many city overpasses and high barriers are painted with this type of paint to ensure they maintain their appearance and structural integrity over time. Recap: paints are classified by binders, then ultimate use and mixed use. Mixed classification paint types include aluminum for reflective, anti-corrosive for protective, asbestos for gas resistant, bituminous for waterproof, bronze for metallic, casein for matte, cellulose for glossy, cement based for masonry, colloidal for penetrative, emulsion for quick drying, enamel for durable, graphite for gas resistant, inodorous for low odor, oil for classic, plastic for quick drying, silicate for heat resistant and synthetic rubber for weather resistance. Alright learners, let us talk about whitewashing and color washing. First up, whitewashing. Preparation of whitewash is the first step. The ingredients are fat lime slaked with water to create a thin cream. Screen in after 24 hours and the additives are gum or rice in hot water. Then how it is applied? Yes, in strokes, vertically and horizontally, allowing each coat to dry before applying the next one. Moving to the color washing, the first step is a preparation. Here we mix pigments like yellow earth, red ochre or blue vitriol into the whitewash. They apply similarly to the whitewash, starting with a base coat of whitewash followed by 2 coats of color wash for new surfaces. There we end the process. Now, and the conclusion here is, distempers and whitewashing are fantastic choice for giving your wall a fresh look without breaking the bank. Follow these steps carefully and your painting project will definitely be beautiful. There we have it. To sum up, in today's lecture, we covered the basics of painting, distempering and whitewashing. Paints do more than add colors. They protect surface, prevent timber decay and stop metal from rusting. Good paints are tough, durable, attractive, affordable, easy to apply, quick drying, crack free and weather resistant. We also discussed about the paint components, base, vehicles, disc dryers, coloring pigments, solvents or thinners. We even looked at the different types of paints. We also understood aluminum paints are reflective and weather resistant, anti-corrosive paints protect metal, bituminous paints are waterproof and great for underwater use, and bronze paint give a new nice metallic finish. So that's what we covered today on painting, distempering and whitewashing. Thank you for joining me today in exploring the fundamentals of building construction. Happy learning. Good day.